Alright, this is the answer to question 1 from the quiz on Monday, June 29th, where I've given you a force field, a vector field, y, negative x, and I want you to find the circulation along a line segment. The way I worded it in class was to ask for the work contributed by the field to the motion along the line segment, but circulation's another word for that. I didn't want to phrase it in those terms because just today we talked about circulation on June 29th, but you were more familiar with the idea of calculating work, but they're one and the same thing. Alright, so to parameterize the line segment from 3, 3 to 2, 0, we write the constants from the starting point, and we write the change from the starting point to the ending point. So that'd be negative 5t to get from 3 to minus 2, and then to get from 3 to 0 it would be subtracting 3. So we write 3 minus 3t, and then we let t range from 0 to 1. So that's the parameterization of the straight line segment. We could check that on Calcplot 3D. And then the formula, we need to know what r prime is. So this pair is r, so r prime is going to be negative 5, which is the derivative of 3 minus 5t, comma, negative 3, which is the derivative of 3 minus 3t. So r prime is this constant vector, minus 5 minus 3. F down here, oh, that will go here, by the way. F, on the other hand, we have to remember is going to equal y comma negative x, where we substitute in what x and y are along this curve. That's going to locate us on the surface above this line segment. So y is 3 minus 3t. Whoops. I didn't mean to finish off that vector. I meant to draw a comma. And now finish the vector. And then f says we put negative x, and x is 3 minus 5t, so that would be negative 3 minus 5t. We're going to integrate from 0 to 1. Those are our time values, and then we're going to dot this force vector, this vector field vector, with our velocity of negative 5, negative 3. So we just have to evaluate this dot product first and then calculate the integral. The dot product is going to be negative 5 times 3 minus 3t plus negative 3 times negative 3 minus 5t. This can of course be simplified quite a bit. And after we do that simplification, I'll leave that up to you. The answer comes out to negative 6. Which means that the field is, because this is a negative number, is working against our motion from 3, 3 to negative 2, 0. And that's something we could probably see if we plotted this vector field and this line segment in Calcplot 3D.